This entire unit is about systems, meaning you have two separate equations and then you are solving for the solution, which means where they intersect. That would be the solution. And you can see that in the form of graphing, doing it algebraically. You'll see a lot of word problems. So we're going to see all different types in this unit. It's pretty quick. I think we only have 3 days of lessons and then a review and then a test. So it goes pretty quickly, but that means that we have another test before the end of the quarter, and we also have a project. So that'll be some more grades. So if you're solving by graphing, it is pretty self-explanatory, meaning that you graph the two lines and then you see where they intersect. So the first thing I need to do, like in number 1, I would need to put both of them in slope-intercept form first. So I'm going to do that for the top one. So y equals negative 4x plus 8. And I'm going to graph that line. So down 4 over 1. And when you're graphing these, I will say, like on the last test, y'all did a great job at this, but you're going to need to be pretty exact on your ordered pairs, because if you are off by a point or something, that could mess up where your intersection is. So they will always intersect at some specific ordered pair on a graph, so that you need to make sure that they are graphed correctly. So the second one, going to solve for y. So negative 3y equals negative 2x plus 18. Divide by negative 3. So y equals 2/3 x minus 6. So I put my y-intercept at negative 6. And I go up to the right 3. And you'll see that's where they intersect. So what is the ordered pair of that intersection? 3, negative 4. Good. So my answer is 3, negative 4. So if I were grading this, I would look at the two lines and then I would look for the solution, which is where they intersect. If we look at the next one, so I'm going to solve the top one for y. So 2y equals negative 3x minus 4. Y equals negative 3 halves x minus 2. So I would go down 3 over 2. And then the next one would be 3y equals negative x plus 1. Y equals negative 1/3 x plus 1/3. So this one, I wanted to do this one with you because it's a little tricky in that how do you graph a y-intercept of 1/3 and then be exact with your ordered pairs? So my suggestion, when you get a fraction for a y-intercept, is to solve for the x-intercept and then go from there. Because usually when they give you a question like this, one of the two, either the x-intercept or the y-intercept, will be a whole number. In this case, the y-intercept is not a whole number, so I want to graph that. So if I'm solving for the x-intercept, what do I need to do to solve for the x-intercept? I set what equal to 0? Y. So I'm going to set y equal to 0. So 0 equals negative 1/3 x plus 1/3. So if I'm solving, 1/3 x equals 1/3. And you end up getting the x-intercept equals 1. So I have an x-intercept at 1, 0. So I'm going to put my point there. Then if my slope is negative 1/3, then I'm going to go down 1 to the right 3. If I go the other way, up 1 to the left 3. Yes, so whenever I connect, the intersection is at this point right here, which would be -2, 1. So the only thing tricky about that kind of example is that the y-intercept is a fraction. So don't try to graph using the y-intercept, try the x-intercept. Yes? Yeah, so in the next lesson we'll check it algebraically. Okay. Okay, so then below that it says check your solution. Oh, is this what you're talking about? Check your solution. Okay, I thought you meant 3.2. So check your solution. What you do to check is you plug in the ordered pairs. So our solution for this was -2, 1. So that's what we got when we graphed. So we're going to plug in -2 for x, and we're going to plug in 1 for y. And then we'll find that if we end up getting a true statement, that it is a solution of that line, or of that equation. So yeah, so I'm going to plug in, so I'm going to do 3 times -2 plus 2 times 1 equals -4. And then I end up getting -6 plus 2 equals -4. And then -4 equals -4. So that's true. And then if I want to check it on the second one, 2 plus 3 times 1, or -2, plus 3 times 1 equals 1. And then -2 and +3 gives me 1 equals 1. So those both work. So there's 3 different ways, or 3 different types of solutions. If you have exactly one solution, that means that you have a line, you have 2 lines that have different slopes. So they intersect at one point. So different slopes. And don't worry about the terminology. I'm not going to ask you anything about that. If something has infinite solutions, that means that they are the same line. So they have to have the same slope and the same y-intercept. So they would both be the exact same line. And you may not recognize that they're the same line at the beginning, because one could be written in slope-intercept and one could be written in the standard form or something. And then no solution would be when you have parallel lines. So what makes something a parallel line? They have to have the same width, same slope. So that means they have the same slope, but they'll have a different y-intercept. So that means that they will never, ever touch. And have any of y'all seen that meme that's like, it's a shame that parallel lines will never meet because they have so much in common? Y'all seen that? Like when you're like browsing on Pinterest one day for some math jokes, you just look it up. It's really funny. It's like, no, I'm okay. Thank you though. Okay, this one it says solve by graphing, but there's no graphs there, so we're gonna have to. We may not even have to graph. We'll see what happens. So I'm going to solve for both of these for slope-intercept form first. So let's put them both in slope-intercept. So we'll take the top one. So the first one, I get y equals 4/3 x minus 8/3. I'm going to try the second one. And should I leave it like this or should I reduce my fraction? I should reduce. I don't feel like I need to say that, but I saw that some people didn't reduce on the test, and I put an angry face next to it. Because you don't leave something as 8/6. You would reduce that to what? 4/3. If that's you, you should be ashamed. I'm just kidding. You shouldn't. Just make sure you fix it for next time. Okay, what do you notice about these 2 lines? Do I need to graph them or can I already tell what it's going to be? You can already tell because they are the exact same. That means that they have the same slope. So they're both 4/3, and they have the same y-intercept. So then it's going to be what kind of solution? Infinite.
So you do kind of need to know these terminologies.
No, you need to know infinite, no solution, and one solution, but you don't need to know the consistent and independent and like all that. Yeah. Okay, so try number 4 and tell me what kind of solution you think it will be. Okay, so I end up getting these two equations, and what do you think it is? No solution because why? They're parallel. Yeah, they have the same slope, but they have a different y-intercept. Okay, so number 5 is a word problem, our favorites. So you ride an express bus from the center of town to your street. You have 2 payment options. Option A is to buy a monthly pass and pay $1 per ride. Option B is to pay $2.50, that should be a period there, $2.50 per ride. A monthly pass costs $30. After how many rides will the total cost of the 2 options be the same? So if I were thinking about option A, I'm going to buy a monthly pass. So y equals, a monthly pass is how much? $30 plus how much per ride? 1. So $1 per ride. So you could write this as y equals x plus 30. That's going to be option A. Option B, it says you're going to pay $2.50 per ride, but is there any like initial fee or monthly pass or anything like that? No. So B would be y equals 250x. So I'm going to graph these, and my suggestion, since I've already worked this problem out, my suggestion is to count by 5s on the x-axis. And then count by 10s on the y-axis. So I'm going to graph both of them. So if I'm graphing option A, I'm going to put my y-intercept at 30. And then since I'm counting by 5s on the x-axis and then 10s on the y-axis, it's going to take 2 points on the x to go up 1 point on the y. So it's going to look like this. Does that kind of make sense? So I'm still increasing by 1 every time, but since my scale is 5s on the x and 10s on the y, it's going to look like this. And then for my B, option B, my y-intercept is 0. And then it is $2.50 per ride. So I'm going, let's see, after 5 rides, how much would it cost? So when x is 5, what would my y be? What's 5 times 250? Like 1250 or something like that. And let's see. And then 10 would be 25. It's easier to do the 10s and the 20s. What about when x equals 20? 50. Because you just take 25 times 2. In my opinion, whenever we do 3.2, it's going to be a lot easier to solve algebraically. So if they give you an option, I would solve probably algebraically, but solving by graphing will work as well. So they intersect at this point, which is the x value is 20, the y value is 50. So how many rides will the total cost be the same? So would it be 20 rides or would it be 50 rides? 20 rides. So when I have 20 rides, that means that it will have cost both option A and option B $50. But my answer is 20 rides. Okay, so then for number 6, determine if it's a solution. I'm just plugging in 1 and 3. So 3 times 1 minus 2 times 3 equals negative 3. So it works for the first one. But you do have to plug it into both. So 3 equals negative 1 plus 4. 3 equals 3. So then I would say yes.